Hello everyone, welcome to my video on Turtle Graphics. In this project, I have developed a Java program inspired by the classic logo programming language. With Turtle Graphics, you can create beautiful drawings and geometric shapes using simple commands. In this video, I'll walk you through the key features of Turtle Graphics, explain how the code works, and demonstrate how you can use it to create your own drawings. Here, I'll also be going through the requirements which had to be fulfilled. Most of this video will be me taking you through the requirements of this project pointwise. Let's begin. The first requirement is that the OOP graphics.jar should have been properly added to the project. Yes, I have properly added oops graphic.jar to my project by going into build path, add external library, and selecting the OOP graphics.jar file that I had downloaded from the LBU Blackboard. Moving on to the requirement 2, the project must contain a main class.java and extend it in the OOP graphics. Well, I have extended the OOP graphics to my Turtle graphics class and not the main class. Due to the specification I had received earlier that I could skip the part about extending it to the main class and extending it directly extending the OOP graphics in the Turtle graphics class. Moving on to the third requirement, we have about calling the about method in the program. Okay, let's run it. When we call the about method in the program, it displays my name. Here, what I have done is instead of the turtle running to create the image OOP, I have overridden it to display my name Swastik. I have handcrafted each and every letters of the turtle to react it in the way that it writes my name. The main class .java has a main method which creates an object of graphics system and further processing is done from this object. No, I have not done this, but what I have done is inside the turtle graphics.java we had a pivotal main method that serves as an entry point of our program. This method initializes our graphic system and sets up the graphical user interface and handles all the further processing. The about method is called and the OOP animation appears when the user types about in the field. As we have seen earlier, when I call the about method, it when I call the about method, the about overridden method calls itself and writes my initials in it. Okay, so this concludes the segment 1 of our requirements. Moving on to the next segment, we have command support, where we will dive deep into the world of turtle graphics and commands that make the turtle graphics interesting. The pen down command working. Yes, the pen down command is working. In fact, I have set up my code such that the pen is always down when we run the program. At the starting of the program, I have given the pen down command so the pen is always down when we run the program. In the program, when we type the command pen down, the case pen down is executed and it has the method pen down that I have inherited from the OOP graphics. Let's see the case of pen down. Pen down. It calls the pen down method that I have extended from the OOP graphics class. Let's run it. When we give the pen down command, it shows the message that the pen's down and the turtle will draw. Moving on to the next requirement, we have a forward command. The forward command moves the turtle forward. If there is no parameter given to it, it shows the message that the parameter is missing. Forward shows that the parameter is missing, and right when we give the command and the parameter, it moves the turtle forward by x unit distance, where x being the where x being the parameter that the user has entered in the command box. Let's see it forward 100. It moves the turtle forward. Talking about how the forward command works. When the user enters the command forward, this line extracts the distance value from the user and passes it as a parameter to the forward method. Let's see the method forward. Yes, the parseInt command entered one part converts the second element of the command entered array, which contains the distance value from the string to an integer using the parseInt method. The forward method then moves the turtle forward by a specified distance, and then the message is shown turtle moved forwards. Sorry, sorry for that. Moving on to the next one. Yes, works, and also yes, I've shown by the forward works. Talking about the backward command. The backward command, when the user gives the command of backward, at first it triggers the case switch case into the backward, and it turns the turtle into the 180 degrees and moves the turtle's head upward. It goes in the forward direction by the distance the user has given it to, and again it turns its head towards the position towards the reset position, that is 180 degrees. Let's see it backward. When we don't give the parameter, it shows that the parameter is missing, but when backward 100, the head is tilted back, and again it moves backward, turning the head's position downward. Moving on to the next requirement. Yes, I've done that. And the turn left command. Okay, if the command matches the turn left, the code inside the case will be executed. Turn left. The line checks if the user has provided a parameter along with the turn left command or not. If the length of the command entered array is not equals to 2, it means no parameter was provided. If no parameter is provided, this line calls the turn left method without any arguments, which by default turns the turtle by 90 degrees. Let's see it. Turn left, turn left. It moves the head of the turtles by 90 degrees. If a parameter is provided along with the turn left command, the code inside this block will be executed. This line extracts the angle value from the user input and converts it from a string to an integer using the parseInt method. It then calls the turn left method with this angle value as parameter, causing the turtle to turn left by the specified numbers of degrees. Let's see it. Turn left. Let's do 45 degrees. It turns the head of the turtle by a 45 degrees and a message is displayed, command successful. Okay, here is another requirement. So the turn left 90 degrees and it moves forward. Let's do it. Turn left 90 degrees and forward by 100. It moves the turtle forward. Yes, so that's it. Move. Turn right command. For the turn right command, what I've done is if the command matches the turn right, the code turn right, the code inside the switch case will be activated. The con- this condition checks if the user has provided a parameter along with a turn right command or not. If the length of the command in entered array is not equals to 2, it means no parameter was provided. By default, this means that the turtle will turn by 90 degrees to the right. If a parameter is provided along with the turn right command, the code inside this block will be executed. This line extracts the angle value from the user, then calls the turn right method with the angle value as a parameter, causing the turtle to turn right by a specified number of degrees. Let's run it, and we can see here turn right. If we don't provide a parameter, it turns the turtle the right side by 90 degrees, but when we give it a parameter turn right by 45 degrees, it moves the turtle in 45 degrees. Here we have another requirement that is to turn the turtle by 90 degrees and forward by 100. Okay, let's reset it and turn right by 90 degrees and forward by 100. Here we have another requirement that the pen up command is working. When a user types a pen up command, it activates the case inside the switch case and the pen up is. You can see it that the pen up command is working and it shows that the pen's up and the turtle won't draw. And if I move it by forward 100, we can see that it doesn't draw any line, which proves that the turtle will not draw. Okay, okay. What I what we have forgotten is that we have cleared everything and we have done all the turn left and the turn right command in a different GUI. So let's redo it. Let's see the commands. At first we had to move had to do forward 100, backward 100, backward 100, turn left by 90 degrees, turn left by 90 degrees, and move forward 100. And we had to do the turn right by 90s, turn right by 90s, and forward by 100. And at last we had to do pen up command, pen up, turn right by 90 degrees, and move it forward by 100. And we can see that it shows an N shape and the turtle is at the bottom left pointing towards the left. Okay, so here's another requirement that I should show a 4-color demonstration. Okay, let's see it. Let's do red at first. Red. If I click here, okay, pen color is set to red. Let's move it forward by 100. Oh, the pen's up. Let's move backward by 100. Let's do pen down, and let's do different color then now. Blue. The pen's color is set to blue. Let's move forward by 100. And blue is done. Let's do blue green. Green. Let's do green. Move it forward by 50. Let's do yellow. Okay, so what happens here is I've not set up a yellow case, so it gives an invalid command, which means it is not in my code. So let's do blue green. Let's do it red. Red move forward by 100. It moves it by forward. Let's do white. Let's move it by forward by 100. And it shows me. It gives a white color line. Okay, here I've set up a different cases for it: the black color, the green, the red, the white, and the blue. Okay, let's move to clear command. For the clear command, yes, the clear command works in the program. When we clear the image on the screen, the GUI dialog box appears and asking us to confirm to clear the image which has not been saved yet. Type confirm if you want to clear the frame. Okay, if we have to clear, we have to do confirm, which clears the code. Let's see it. When a user enters the reset command, it brings the turtle to the middle of the screen, facing the turtle down. Let's do it according to the requirements. Reset command turn right and forward by 100. And when I type the reset command, it brings the turtle back, turning its head toward the bottom of the screen. This concludes segment 2 of our requirements. Moving on to the next segment, we have validating commands, where we will handle the errors and act accordingly when the user gives the wrong commands. Reports invalid command. Yes, my code does report an invalid command. Let's see it. When I type xxx, it throws a message that it is an invalid command. Let's see it. Where is the invalid command? And yes, here it is. When there are no cases, when the user gives different commands other than the cases that I have listed, that is save, load command, clear, confirm, and so on, it displays a message of an invalid command. Moving on to the next one, detects valid command in missing parameter. Yes, as we have seen in the earlier segment of the requirement, when there is a valid command but the parameter is missing, it throws a message that a parameter is missing. Parameter, okay, let's type forward. It shows that the parameter is missing. To show you the code here, it checks that whether the commands entered is the length of 2 or not. If it is not at the length of 2, that is a command and the parameter, it shows that the parameter is missing. Moving on to the next one, it detects the non-numeric parameter. Yes, it does detect the non-numeric parameter. Let's see. When we type forward xxx, it shows that it is a non-numeric data for a parameter. Here it is. The program detects the non-numeric parameter. When we type a forward XXX, it reports the user that it is a non-numeric parameter. It catches the exception and throws a display message that it is a non-numeric. Here, what's happening in the code is that when a command is entered by the user, it stores it in the distance and converts the distance into the int. The distance if the given value is not in the integer form, it throws an exception of the non-numeric data for a parameter. Let's move on to the next one. Bounding the parameters. Yes, I have bounded the parameters here. We can see that the turtle can move only within the distance of 0 to 100. Forward, forward 100, the turtle moves. But if we type forward 150, it shows that please enter the value between 1 to 100. Okay, yes, this concludes our segment 3 and moving on to the segment 4 of our turtle graphics journey. In this segment, we'll explore the functionalities of saving and loading commands and images within our program. The save command works. Yes, the save command works when the user gives the command. First, it goes into the switch case, and in the switch case, it has a method called save image. Let's go there, and in in here, the line retrieves the current drawing as buffered image. The get buffered image method is likely to retrieve the current state of the drawing from the turtle panel and convert it into the buffered image object, which is a standard form in Java. Let's have a look. Let's let's draw square and 50 draws a square, and let's save it. Save it with the name of SQ. Image saves successfully. And the load command works. To show the load command, when a user gives the command, first it goes into the switch case. And in the switch case, there is a method called the load image. Here, this is a private method named load image that takes a string parameter as the file name. It is responsible for loading an image file with a specified file name. If there is an unsaved work, it prompts the user to confirm the dialog box asking it if they want to continue loading the image. Let's have a look. Mm, First let's load the image that we drew earlier. Let's load SQ. Do you want to continue loading the image? Yes, we do. And it loads the image in the circle. But let's clear it, let's confirm it. And if we have drawn, suppose, where 100, and if we had to load an image, load SQ, mm, yes, it gives us the loaded image. Okay, moving on to the next one. We have to save all the command previously typed as a text file. Yes, when a user types the save command, what I have done is I have created a file writer object and initialized it. The file name is the name of the file in which the commands are stored. Its extension is .txt, and I have used this for each loop to extract each command from the commands array. After the loop, I have closed the file writer object. Let's run it. Let's draw something forward by 100, turn left by 90 degrees, forward by 100, turn left 45 degrees, forward by 100, let's turn right by 90 degrees, and let's move it forward by 50. Let's save the command. Save command by the name of draw. Command was successful. When we save it, it is saved as a .txt file in my. Let's refresh it. Yes, it's saved here. And when we need, okay, we'll come to the loading part. Here it is. Load a text file. In the load command, I have used a file object to reference file where the commands are saved. Then pass the file object to the scanner object named myReader, which reads each line from the file. Then each command are added to the commands array, then passed to the process command method for execution. Let's run it. Let's load command and draw. Do you want to continue the loading command? Yes, we do. It gives and it shows what we have drawn earlier. Moving on to the next one. Warning is not, the current image is not saved. Yes, if we want to clear it, it shows that the current image is not saved, and we have to type confirm if we wish to clear the frame. And yes, we can type confirm, we want to clear the frame. Yes. A warning is displayed using a GUI box if the current image is not. Yes, as we have just seen it. Let's do it again. Reset. Set the turtle forward by 100, and let's draw a square there. Square 50. Okay, now let's try clearing it. Clear. The GUI box appears, giving us the warning. We have to type confirm, confirm, and yes, it's clear. Welcome to the final segment of our Turtle Graphics adventure. In this part, we'll delve into the powerful concept of inheritance in our program. For the first requirement, we have the override about method and contains my name. As previously demonstrated, when I call the about function, it displays my name along with the message and states my full name. Let us have a look. Let us call the about function, and the turtle moves so that it gives my name along with the full name as a message. For the code that I have written, for each letter I have moved the turtle in a certain way to give my initials. Diving into the second question, we have implemented a square length command. Turtle should wander around the edges and return to its original position. When the user types the command, it makes a square with the desired size and length. Let's type square 100, and it gives a square, and the turtle is facing down in the reset position. Here, the instructions are handcrafted into the program to give the user the desired parameter. The length will be stored here, and and how much the length is given by the user will move the turtle forward by that length. Turn ready, and so on. Moving on to the next one, we have that append color should take different parameters and the error checking should be there. Okay, let's say this. The pen command ensures that it receives three parameters representing RGB values. Let's see, pen 255, 255, 0 should give a yellow color. And our pen color is set to RGB value. Let's move it forward by 100. It gives a yellow color. Furthermore, if we see pen 255, 0255 set to RGB, let's turn right and move it forward by 100. We can give any values. Let's say it again, pen 241, 50, and 80. Let's move it forward by 100. As you can see, it gives a different color. But what happens if we give a value that doesn't exist? Pen, a color ranges from 0 to 255. Let's give it 260, 0, and 500. Suppose it throws an error. Illegal RGB values. The RGB values must be between 0 to 255. Let's have a look at the code. Here it is. The pen command takes the for length for, as in the pen, and the three parameters, and the int red is converted into integer, green, and so on. And if it doesn't fall between 0 to 255, it throws an error called the illegal argument exception and throws the message illegal RGB values. RGB values must be between 0 to 255. For the next one, we have a pen width. Okay, first let me explain the code. The pen width command ensures that it receives only one parameter representing the new pen width. If the input doesn't meet the requirement, it prompts the user for a valid pen width. Once provided, it attempts to parse the width as an integer. If successfully, it sets the pen width using the setStroke method for all the future drawings operations. However, if parsing fails due to invalid input, it throws an error for please input a valid pen width. Let's see it. Let's move it by forward 100 at first and see the pen width. And now we can do pen width and set it to 20. And let's move it forward by 50. And the pen width is set to 20. Let's turn the right and width to 10. Let's move it forward by 100. You can see that the pen width has been changed throughout the program. Moving on to the next one, we have that a triangle with only one parameter draws an equilateral triangle. Okay, when a user gives the command triangle, it goes inside the switch case and checks for the triangle. After that, it checks whether the parameter is 1 or 3. If the parameter is only 1, the method equilateral triangle is called. If the parameter is 3, the method drawTriangle is called. While the code for equilateral triangle is simple, for the scalene or the triangle with three different sides, I have kept a condition for the triangle to be made. As we all know that in a valid triangle, the sum of length of two sides is always bigger than the other. Let's go inside the draw triangle, open declaration, and here I have made it so that if the side is the both smaller side should be bigger than the third side. So if the user gives an invalid length, the user is shown an error message. I also has compu- I have also computed the cosine's law to formulate the triangle. As you can see here, I've used the cosine's law to formulate this triangle. Let's run it and see. Triangle, if I give only one parameter, it runs as equilateral triangle. An equilateral triangle drawn with the sense is given. And if I triangle with 10, 20, and 50, here we can see an error that the both sides are not greater than the 50. If you calculate it, 20 plus 10 is 30, which is not greater than the bigger side. So it throws an error. Let's do it again. Let's clear and confirm to clear it. Let's reset it. And if we draw triangle, the parameter with side 50, 50, and 60, and it draws a scalene triangle. Okay, let's do it again. Let's do it. Clear it first. Clear, confirm, reset. Let's do triangle 10. Let's do 100. Let's do 100, 150, and 50. Let's do 70. And here we can see that the scalene triangle is drawn with three parameters, and it also throws an error if the length of side is not greater than the third side. So yes, it does an equilateral triangle. Okay, by this we have concluded our Turtle Graphics journey. We have had the pleasure of diving into the world of creativity and discovery, pushing the boundaries of what's possible in programming. With every stroke of the turtle's pen, we have uncovered new ideas and expanded our skills. I want to extend my heartfelt thank you each of you for joining me on this adventure. Until next time, happy coding.